Hello and welcome, everyone. How are we doing? Pretty good? Yeah? All right, nice crowd. Thanks for coming along. This is for bring your own IP address into the cloud. Who here was at the keynote and heard the announcement from Werner? A couple of folks. Who here was excited? I was excited. I've been seeing this thing floating around for a while. So yeah, really excited to be here today and talk about what bring your own IP really means for AWS customers. So how you can bring an IP address range to AWS. I'm Matt Lewis. I'm a principal solution architect here at AWS. Been around for about almost 5 years now. I've seen this request come up a lot, so this one was a little bit dear to my heart. I had a lot of customers that were asking for this, and the fact that we went in and turned that into a service or a product feature is just amazing. I really love that. Now, for those of you who have seen a couple of sessions of mine before, you'll know that I always start with the VPC foundations. I feel that the VPC is really the foundation of when you're building think of it like a skyscraper or your application stack. The VPC really starts there. And what I want to do is just set the scene for where elastic IPs are important and then where bring your own IP is important. We'll dive into the nitty-gritty, and I've got a bunch of terminal screens here that we can throw up and go through on how it actually works. But I really want to set the scene for why is bring your own IP important. So, like I start a lot of sessions, we start with AWS, and we start with EC2 and Amazon VPC here. And when you have a VPC, it's a CEDAR address range. You've got availability zones. You've got subnets inside those availability zones. Now, what you'll notice here is as we're building out instances inside those availability zones, inside those subnets, they're in this case, privately addressed. The VPC has a CEDAR address range of 10.100/16. So that's an RFC 1918 range. I think there's a newer RFC that it's included in as well. But this is used for non-routable internet, non-routable addresses that aren't going to be routed out onto the public internet. So we've got public subnets, private subnets, public being some that have access to the public internet, private subnets have access to only the VPC in this case. We've got the internet. We've got services that sit outside of the internet. So S3, DynamoDB, SQS, SNS, IoT, Lambda. There's quite a few that actually sit in the AWS region, but outside of the VPC. And you need a public IP address to connect to those in a lot of cases, unless you're using an interface endpoint or a VPC endpoint. So then we have an internet gateway. So the internet gateway is important for the topic that we're talking about here, bring your own IP, because that's where the public IP addresses in Amazon sit, at the internet gateway. And so routing is quite important. I mean, we want to determine where traffic's going to go. So within a VPC, we have a 10/16 via local route in this case. We've chosen 10 for our range. And then we have a default route via the IGW. So traffic's going to go up via the IGW for those public subnets, and you'll see the route table there is via or for the public subnet. Then we have the elastic IP. So the elastic IP is a public IP address that Amazon owns. You can allocate them to your account. You can allocate them to EC2 instances. But when you do that, you don't actually see that public IP on the instance. So if you went onto let's say it was a Linux instance, you jumped in there and did an ifconfig, and you had a look at the IP address on instance A. In this case, you're going to see a 10.1.1.11 address. You're not going to see the public address there. What happens is when traffic goes from that instance and goes out through the IGW, it will be natted to the public address range. So we have a static one-to-one natting of the private internal VPC range, or VPC address in that particular case, to the public address. It's just a single address mapping. So that way, anyone from the public internet wants to reach your instance A, it's going to hit the 54 address. Or if you talk out to the rest of the world, you're going to be sourced from the 54 address. So we can talk to things like the internet and other services. Now, within the VPC, we can have multiple route tables. So we've noticed we've got another route table, we've got another route via local, we've got a default route via an ENI of a NAT instance in this case. Now, it's a good idea to use NAT gateways where you can, so let's swap that NAT gateway out with a NAT instance with a NAT gateway. Now we actually have another elastic IP for the NAT gateway. You can assign elastic IPs to network load balancers as well. When they talk to or are reachable from the public internet, they have an elastic IP. So your external communications to the internet in a public fashion is done via the IGW and elastic IPs. And if we add a bunch of other services here, just so you get the full picture, we've got some prefix lists via a VPC endpoint. We've got some on-prem routes via your direct connect or VPN. So we've really built out this route table to show where you can send traffic. But again, going via the IGW does need those public addresses. Here we've got VPC peering, and you'll notice that you've got VPC-B via PCX123. Now, there's no natting between VPC peering. You're talking from a 10.1 VPC-A to maybe a 10.2 VPC-B, okay? But the IGW has that natting, has that public IP. So an elastic IP, what is it? Well, Amazon has a bunch of public IPs, and we give those to you in the form of a single address. When you go into your console, you say, I'd like an elastic IP, please. We give you an elastic IP. We randomly select that from our pool of IPs. And there is a JSON available. You can go and have a look at all of AWS's public IPs. It's easily searchable on the internet. And that JSON lists all of Amazon's public ranges for S3 and other services, and EC2 elastic IPs included. Now, when you associate an elastic IP with an instance, it's, again, that one-to-one mapping, but you don't choose that IP. So you could disassociate that IP and get rid of it and say, I don't need it anymore, but then it's pretty hard to actually say, hey, actually, I do want that IP, bring it back. It's going to go back into the pool, and it's going to be lost. Someone else might get allocated that. And I've had that question from customers. They say, we accidentally got rid of our elastic IPs. We whitelisted some public sites. Can you please give us those elastic IP addresses again? That's fine if they haven't been reallocated, but imagine if they'd been reallocated to another customer. Then we have to go to that customer and say, oh, hey, Bob wanted those IPs, actually. Could we take those back and then give them to Bob? I mean, so they're really, consider them like ephemeral IPs that you get given a random IP from our IP pool and use that as a public IP. That's really what an elastic IP is. It's that one-to-one natting that sits at the edge there. And we advertise all those ranges out to the public internet. We advertise them to our other regions. So they exist within the public realm of AWS and the public internet as well. So your IP address, in some cases, it's not just a number. Some companies build up their reputation based upon their IPs. Now, it's always a good idea to use things like DNS, and that's why DNS was invented. Imagine if we had to remember addresses like this for something like Amazon.com, and you had to punch in this IP address every time. That'd be kind of arduous. But sometimes customers want to keep their IPs and say, well, I've been using this IP in my compliance, I've been using it for whitelisting, etc. I'd like to keep using this, but I've heard about this thing called AWS, and how can I use that same IP in AWS? Now, it can be catastrophic in some cases when you have hardwired IPs associated with your systems, and then you change those IPs or need to change those IPs. One example is an interesting case. I was working in the telco industry, and we were working with large banks to do ATM deployments, and we had a bunch of CPEs that we were, or customer premise equipment that we were deploying in each device in each ATM. And what would happen is it would cost X dollars for us to do a config change on these CPEs because they weren't allowed to be accessed externally at that point in time for compliance and a bunch of other crazy stuff. So we had to have a security guard with us. We'd go in and access the CPE, hardwire a bunch of stuff, close it up, lock it up, walk away. Now imagine if you've got 3,000 CPEs and you have your data center and you need to change the destination of your data center. And you have to revisit each one of those 3,000 CPEs. That's actually a true story that happened about 10 years ago. But in this case, if your IP changes, it can have detrimental effects. Hence why we'd like you, as customers, to be able to bring your own IP to AWS. If you have those IPs that are hardwired, you can now import those into AWS. We assign them to you in the form of a pool, and you can allocate addresses out of that pool. They're your IPs. They're the IPs you've been using for as long as you've been using them. You can now use them as elastic IPs in AWS associated with EC2 instances. Pretty awesome stuff. This is very exciting for me. Okay, so why would you want to do this? Well, I mean, keeping your IP addresses reputation is one thing. We talked about that. It's important. So reputation is really who you are in the public internet. And there are folks out there that do indexing and spam reports based on emailing to say, hey, we have these IPs, and these are the IPs that have been doing spamming, and these haven't. And there is a reputation system out there for public IPs. So your IP is part of how you are perceived in the public internet. Whitelisting, we talked about that. So you've got something hard-coded, you've got sites that know that this site, this head-end site, is yours. So whitelisting at an IP level. We always say DNS is great, but it doesn't always work like that, like the ATM example I had. Migration. You might be using these IPs in your data center, and everyone knows how to reach those IPs. They've got systems that use those IPs. But then you say, well, hold on. I want to use some scale from AWS. I want to use auto-scaling. I want to use VPC. I want to use all of the cool things that AWS have. I want to use some serverless architectures and connect them to an EC2 deployment or something like that. With this, you can bring your own IPs and you reuse those same IPs that you use with your on-premise data center. And redundancy as well. So we'll get into the details now, but you can have a set of IPs that are running on premises, and you could, for example, decide at a certain point in time you want to start advertising those IPs via AWS and use that as a hot standby. So I'll show you how that's actually going to work today. All right, so this is great, right? Yeah? Yeah. IPs sometimes aren't the most exciting topic, but you'd be surprised at how many customers say, if I can't bring my IPs, I don't know if I want to use the cloud. So we want this kind of functionality. We want to make it easier for customers. All right, let's talk about what the process looks like. So firstly, we've got a terminal console here, and I apologize for those of you like myself who are vision challenged. I've tried to make the text as big as possible. This is basically a recreation of an AWS CLI. So the first step is really provisioning the IPs. So bringing the IPs to AWS. So in this case, we've got the AWS region, and what we launched today, what we announced today is actually the public preview of Bring Your Own IP. So not GA, but the public preview, and this is how the public preview will work, and there are some other details here, but in this case, it's available in our Portland region, and you would specify US West 2, your IP addresses, and then a description if you like. What's going to happen then is you get this output where, okay, we've accepted those IPs and we're going to look at those, and they're actually in a state of pending or pending provision. So what will happen is you've said, I'd like to bring these IPs to AWS. We've said, okay, we'll check it out and see if we can bring those to AWS. We're then going to go and investigate and make sure it meets the criteria, which there are some criteria, and after a certain period of time, they'll be active and available for use. So if we just keep going here, and so we do a describe on the IPs, you'll see they're still in a pending provision state. But then, sometime later, we do a describe, and the state changes to a state of provisioned. Okay, now provisioned means we've accepted those IPs, and you now have a pool of those IPs available to create elastic IPs. It doesn't mean we've started advertising them to the internet. We'll get to that. But provisioning has been completed. Okay, great. AWS has accepted the IPs. So now if you want to advertise the IP, so you've got a /24 block or a /23 block that's been provisioned, and you now have decided, okay, it's time, I'd like AWS to advertise those IP addresses to the public internet. Once you use the advertise BYOP CEDAR command, and we're specifying the IP range, we've got a /23 range, a 130, 137, and we'll come back to that 24.0 range in a second. That's a real range that we imported. And after you say, okay, I'd like to advertise these, they turn into a state of advertise. Now what that means is we're going to use our peering connections where we have BGP sessions and peering partners and service providers, and within our backbone as well, not just other internet service providers, but also our own backbone. We've started advertising that, in this case, the /23. So we've said, hey, we have this IP, and if you want to reach this IP on the public internet, please come via us. Now at that point, it's probably a good idea to stop advertising this range from your on-premise data center because you don't want any kind of funky routing and that sort of thing. Now, that is a more advanced use case, and if anyone's interested in chatting about that, come and talk to me later. But basically, the idea would be you probably want to advertise it from your on-premise, or you probably want to advertise it from AWS. Otherwise, you could see indeterministic traffic paths, which aren't good for your customers. Okay, so the subnet's now being advertised by Amazon. Awesome. So what do we do now? Well, let's describe the pool and see what IPs we've got. So we're using the AWS EC2 describe public IPv4. We're using, again, it's in that region. When you do bring a IP range to AWS, it does get brought into a region. So you'll notice that we were specifying US West 2 in this case for all of these commands. That means that that IP range is going to exist in US West 2 or our Portland, Oregon region. So here we've done a describe. And you'll notice this is a /23, so we've got 512 addresses that are available. The start address range is 24.0, the end address range is 25.255. Okay, so we have this IP pool there now that we can start creating elastic IPs from that. Okay, we have a total address count here, available address count as well. Okay, we'll clear that. Now let's allocate an IP address from the pool and turn it into an elastic IP that we can use for our instances. So again, it's just the allocate address command with the region and the VPC and the pool name. So we're, in this case, assigning it for use with the VPC. And then you'll notice here, public IP, we've now been given a 130, 137, 24, 135. So we've randomly gone and picked an address out of that pool and we've turned it into an elastic IP. Well, that's fine, but what if you actually want a specific IP? So we've got a random IP. Well, what you can do is specify, I'd like to take the .1 or the .5 or the .15 and turn that into an elastic IP. So again, similar command, allocate address, US West 2, domain VPC, and then address. So in this case, we're choosing a 130, 137, 24.77. Okay, we're going to get a description or a response there, and you'll see that the public IP is being allocated there. We've got an allocation ID in the domains of VPC. All right, cool. Now, if we wanted to take an Amazon IP and not use one of the pools, you can still do that. You don't have to use the bring your own IP range. You can still use the public Amazon ranges as well. So let's just do that really quickly. So we're saying EC2 allocate address, region US West 2, domain VPC, awesome. And now we get given another IP. So we've been given this is a different allocation ID, and we've been given, you'll notice, a 5241 address, which sounds like an Amazon Elastic IP. If anyone's worked with Elastic IPs, they're normally 54 or 52 or out of the Amazon ranges. So we've allocated an Amazon address range now. Okay. So now let's describe and see what IPs we've got there. So we've got, we're doing, again, region US West 2, describe address, and you'll see here that we've got two IPs here, the 131.724, 135, which was the randomly allocated address out of the pool. So this is our pool ID, so we've got that IP allocated out of the pool. And this was the first one that we allocated. And then out of the same pool, remember we did a more specific, so we've got a .77, so that was the second address from the pool. But then also, you'll notice here from the public IPv4 pool, we've got an Amazon address, the 52 address that we did. So when you describe the IPs, you're going to be able to determine where did they come from. They came from my bring your own IP pool, or they came from my Amazon pool. Okay, so the third came from Amazon. Cool. All right, so if we describe just the pool, so we do a describe public IPv4 pools, and you'll notice here that we've got 510 addresses available, whereas before we had 512, and we've got two addresses there. Well, actually, that's the start and the finish. But the total IP address count is 512. So your Amazon address, the third one, didn't actually come from our pool here. Okay. Now, what if you want to withdraw the advertisement of the address at any stage? How do we do that? Pretty straightforward. It would just be a withdraw, bring your own IP seeder, the region again, and the range. And what that's going to do is basically turn the address pool back into a state of provisioned. Okay, so now it's provisioned and ready to be used, but it's not advertised. So if you did a lookup or a trace route or something similar on the public internet for this range, it's not going to be advertised by Amazon. So you can provision, or you can provision the IP pool, but then advertise the range, or then not advertise the range. Now, we also want to be pretty clear here that IPs are considered property by the owners of the IP, and they're bringing it to Amazon for advertisement. If you wanted to take that IP back for your on-premises, you can absolutely do that as well. Okay. So that would be deprovisioning the range. So after you've deallocated all of your Elastic IPs, you've turned it back into a state of provisioned, you can then say, all right, I'd like to deprovision this IP range, and Amazon will hand that back to you. So we're deprovisioning, in this case, the /23, and then it would go into a state. Again, when we were provisioning, it went into a state of pending provisioning. With deprovisioning, it would go into a state of pending deprovisioning. Okay. So let's check out the console really quick. And this is, again, the text is really small, but basically you can see here that we've got 3 IPs, and as I built these slides out, I actually allocated these IP addresses, and this is a screenshot of the console I was working in, and you can see we've got the 3 IPs that we were working from before. So we've got the 2 on the top of the 130, 137, we've got the 135, which we randomly allocated, we've got the 77, which we said we wanted specifically to choose that range, and then we've got the 52 range, which we allocated as a normal Elastic IP. So when you've got the pool of addresses and you allocate Elastic IPs from that, you'll see them in the console just like you would normal Elastic IPs. So a couple of questions on this. Where is the preview available? Right now, we're only doing the Bring Your Own IP preview in US West in our Oregon region. So that's definitely where you can try this out. You can jump in there and import IPs or allocate IPs and do all that kind of good stuff out of our Oregon region. What's the most specific prefix I can bring? Good question. /24. So the most specific prefix is a /24, and this coincides with what we see in the public internet as well. If you work with a tier 1 service provider in a lot of cases and you have provider independent addressing, you can probably only advertise a /24 anyway. So we decided to keep that as a range as well. And if you want to bring your own IPs, you've probably got a /24 range to begin with. So this was a nice delimiter that we decided to keep with. Are there any major differences to what I saw here and the public preview? Well, in the preview, you actually have the ability to allocate addresses. Now, with the provisioning stage, we've actually got a bunch of our account teams that would work with you to do the provisioning of the addresses. It is a public preview, and you can bring those IPs to AWS, but we'd have someone from AWS working with you to do the actual provisioning itself. But once you do have that pool of addresses there and available, you can then go in and use the allocate and deallocate addresses, etc., to create Elastic IPs and that sort of thing. How do I sign up for the preview? Really straightforward. You just jump to this site. The link is kind of long. If you guys want to take a photo, that's fine. There was the announcement this morning. There is a public blog post that lists this link as well. Anyone's welcome to jump on there. There's a form you can fill out. We'll reach out to you and work with you on how you can bring your own IPs to AWS. Did everyone get that one? I don't want to go through this too quickly. Okay, great. When's the preview available? Now. It's available right now. You can jump in there and start bringing your own IPs to our Oregon region. Pretty awesome. Now, bring your own IP is kind of one of those things that I felt like we should have had it a long time ago. It's a very simple feature where you can say, I'm going to bring some IPs, I'm going to allocate some IPs, I'm going to create some Elastic IPs. But the work that actually went into bringing this feature and having direct exposure to the folks that were building this thing, I mean, it's just like any other feature. There's a bunch of stuff that goes into it. But the thing I love about this is it's actually quite simple. So that said, if you guys want to fill out your evaluations when you get a chance, I'll be hanging around up here for the next 20 or so minutes to answer any questions. But thanks for coming along, and look forward to seeing you next time.